Today's lesson is on transformations in the Cartesian plane, and this will be the last lesson that we do for this unit. Question 1 asks you which transformation changes triangle A into, and then you have to find the other three triangles. So what takes it from triangle A to triangle B, to triangle C, and to triangle D? So the three translations that you will have to choose from, or transformations, are translating, which is like a slide, so moving to the left or to the right or up or down. So when they talk about translation arrows, you're drawing arrows to kind of show which direction it's going. The second type is a reflection. So remember, this is like a mirror image, so when they ask for a mirror line, you could draw kind of the dotted line and label it M for the mirror line on the graph to show where it's reflecting. The third type of translation is a rotation, which is what we used to call like a spin or a turn. It'll most likely rotate around the origin. So you have to see, how does it get from A to B? Is it translating like a slide? Is it flipping like a reflection? Or is it spinning like a rotation? Question 2 asks you to find two different points, F and G, so that triangle DEF, so D and E would connect. So triangle DEF and DEG would need to be congruent with A, B, C. So remember, congruent means the same size and the same shape. Does not have to face the same direction. So if A and C are 2 apart, like D and E, it means that your third point needs to be 2 away but perpendicular to the center here, right? So you could go in a couple different directions to make 2 different triangles, and wherever your point is, you're going to put the ordered pair in the brackets here. Now, for question B, it asks you which transformation takes triangle ABC to DEF, and how do you know? So how do we go from here to wherever, if this is your DEF? Is it just that it's sliding? Is it rotating, right? And then how do you go from ABC to DEG? So if DEG is facing upside down, how do you get there? So both of these should be one of our 3 transformations, either a translation, a reflection, or a rotation. Question 3 asks you to design and perform your own transformation. So I rotate ABCD, here's ABCD. How many degrees clockwise? So usually when we're doing degrees, we're looking at groups of 90, so 90 degrees, 180, 270. So you could do a quarter, a half, or a 3/4 turn, and it's going clockwise. Once you have finished doing that rotation, you will write the new points, right, for A image, B image, C image, and D image. So you're just writing down those ordered pairs. Part B asks you to translate this new quadrilateral that you've created. So not the original, but the new one, if you did 90, if you did 180, if you did 270. And you're going to translate it how many units up and down and how many units right and left. So these first blanks are where you're writing a number, so like 3 units, 2 units, it's up to you. And then this one you're putting the direction. So you're either writing up or down and you write it on the line, and then right or left. Once you finish translating that, however many places you've asked, the new shape you'll create, we're labeling with the asterisks afterwards, and you will write in those points. So you'll all have different answers. This one probably won't be in the answer key. Question 4 asks you to draw a coordinate grid on grid paper. So you're making your own kind of graph or grid like this, and to plot these points. So A11, B23, C33, and D31. So you're plotting these points. Join the points. What special quadrilateral is ABCD? Okay, so you're combining the 4 points. What shape is it? Is it a rectangle, a square, a rhombus, a trapezoid? Right? What special shape is it? Is it a parallelogram? Then reflect ABCD first through the x-axis and then reflect the image through the y-axis and label that image ABCD. So remember, if we're first reflecting through the x-axis, that means all of our y values will switch, right? So your y1 will become y negative 1, y3 will become y negative 3, okay? And then when you reflect through the y-axis, those new points, it's the x value that will change because we'll be flipping it onto the other side, so that will become negatives. C asks what single transformation takes ABCD to ABCD with the asterisks. So you're looking, we've done 2 transformations here, but what could also get you there in one step? So instead of 2 reflections, is it a translation? Is it a rotation? Is it a different reflection? How could you get there? Question 5 asks you to draw a coordinate grid on grid paper. So if you have grid paper, you'll need your y and your x, and then it asks you to draw a scalene triangle on your grid. So an equilateral triangle has 3 equal sides, an isosceles has 2 equal sides, a scalene has no equal sides. So when you are drawing your triangle, it needs to have 3 different side lengths. So sometimes it's just easier, you don't want your point to be in the middle, your apex. It's easier if your apex is off to the side. Then you're more likely to end up with 3 different lengths. Or you could even have like a right triangle like that. Question B asks you to reflect the triangle through the x-axis and then the y-axis. So first, we're crossing the x-axis, so we're flipping the top and the bottom, and then we're crossing the right y-axis, so we're switching lefts and rights. C asks you to reflect the original triangle, so that's the first triangle that you had, through the y-axis, and then reflect the image through the x-axis. So what we're doing is basically doing our 2 reflections in different orders. For part B, you're reflecting through x and then through y, and for C, you're reflecting through y and then through x. And they're going to ask you what you notice about the images at the end. Are they the same? Are they different? They're then going to provide us with an investigation. So in question 5, performing the transformations in reverse order, so x and y versus y then x, did not change the result. So they want to know if this happens with any 2 transformations. So they're going to give us a translation and a rotation. So first they ask us to translate 4 units left and 1 unit down. So, and then rotating 90 degrees clockwise around the origin. So A asks us to start with triangle A, do T first, and then perform R, and label the resulting triangle B. So I'm going to do this in yellow. So if I'm going 4 units left, 1, 2, 3, 4, and 1 unit down, there's my first point, and then 1, 2, 3, 4, and 1 unit down. 1, 2, 3, 4, 1 unit down. And this is my triangle B. Then I'm going to perform R. So I need to rotate it 90 degrees clockwise around the origin. So I know that I'm going clockwise and I'm going around this point here. So if I am touching this axis here, 1, 2, 3 points over, then I know I'm also going to touch it 3 points up, and then it goes in, and my other mark is not on the axis, it's floating on the side. So this will be my new B in yellow. Now in green, I'll do B where I go in the opposite order. I'm going to do the rotation first and then the translation. So here's my rotation. I'm kind of 2 up, 1 over. So I'm going to go 2 over and 1 down because I'm rotating 90 degrees. So there's my first point. And then it's going to come down and over. So this is the beginning, my first translation for C. And then I need to move 4 to the left and 1 down. 1, 2, 3, 4, and then 1 down. 1, 2, 3, 4, and 1 down. 1, 2, 3, 4, and 1 down. And so here is C. So do triangles B and C coincide? So they're not layered on top of each other, but they are just a transformation away, right? We would need to go a certain number down and a certain number to the left in order to take B to C. D asks if you can obtain B from A by a single rotation around the origin, reflection, or translation. So if you can get from A to B, and I don't think you can because it's got a bit of a flip to it and it's a combination of things. And then start with triangle A, do R, which translation do you need to get to B? So if we have A and we've done our rotation, well, that's what we did here. What translation do we need to get to B? Well, we need a transformation, right? Or a translation. So how many up? 1, 2, 3, 4 up and 1 to the left. Okay, so that will be what you're putting for question E. This assignment will finish with one more investigation where you are considering 2 transformations. So I won't do this one with you, but I will kind of talk you through it before you try it out. So they've given us 2 other transformations. So F is a reflection through the x-axis. So remember, here's the x-axis. So this is your mirror line. So this would pop down here and flip around. R is a rotation 90 degrees counterclockwise around the origin. So counterclockwise is going to drop to the left around this point. So if it goes up to here, then it's going to go over to here and come out this way. How does performing F then R compare to performing R then F? So question A asks you to start with this trapezoid, do the flip first, and then the rotation, and label that M. And then for part B, start with L, do the rotation first, and then you're going to flip it across the x-axis, and that will be N. So then they're asking, do they coincide? Are they on top of each other? Then start with trapezoid L, do the rotation, and then which reflection do you need to perform to obtain M? So what do you need to do to get it over here, and how do you know? Bonus, you can obtain M from L by a single reflection, so find the mirror line. It'll be a little bit of a trickier one, but you can go ahead and try that one out. There'll be some questions on a Google form at the end of this assignment for you to fill out, and feel free to let me know on Zoom if you need any help, especially as we get closer to our next quiz.